If you watch my videos, you know that I've got a workshop, and in my workshop I make a lot of gym equipment. As a matter of fact, I've made the vast majority of the equipment I have in this gym. However, one big tool that's been missing from my workshop for a long time, that's been on my list of things I need to get someday at some point, is a 3D printer. But it finally happened. It's getting to the point where I've got people asking me to build them things, and it just so happens that some of these additional little odds and ends would be way cheaper, way easier, and way more convenient, and I could actually do a higher quality job if I had that 3D printer to supplement my welder. So I finally got a 3D printer. I've been teaching myself how to use it, and of course one of the first things I did was make my kids toys. Of course, obviously. But once that was done, I made myself a toy, like this little deadlift man for my set of keys. But then I thought, no, really, what are some problems that I've been needing to solve in my gym that I could solve with a 3D printer? And one thing that occurred to me was that I need a deadlift solution. Every single time I'm trying to load plates or unload plates for deadlift or snatch or clean or basically anything else where the bar is going to be on the ground, I have the same problem everybody else does. I have to lift the bar with my left hand and try to slide plates on with my right hand. That's a pain in the ass. So I do what everybody does. I use a change plate on the floor to ramp the bar up on top of. But that's a pain in the ass, as we've all figured out. So I solved this problem temporarily by keeping these little squares of rubber next to my squat rack for about 6 months. And although these are better than the plates, these are still a pain in the ass. It lifts the bar off the floor for me, but it doesn't keep the bar from rolling off. So I'm still stuck in a position where I'm holding the bar with my right hand so it doesn't roll off this little piece of rubber, and then I'm using one hand to slide the plate on. So better than nothing, better than a change plate, but it still sucks. I need some deadlift wedges. So I printed some. This was the first idea. Narrow profile so it doesn't get in the way of extra plates. Fairly high elevation so I can easily load plates or take them off without any problem, even if it sinks into the floor mats a little bit. Problem is, this is boring. This is milk toast. This thing kind of sucks. I haven't tested it yet. It might be great, but it kind of makes me sad. So then I made this one. This one's already cooler, obviously, because it's a different color. Also, it says this shit ain't gonna lift itself, which will add 10% to my PR. On top of that, it's got a very low ramp, so it's gonna be much easier to roll much heavier weights on top of this. It's also wider, so I don't have to be as precise with my aim. I can basically throw this on the floor and it's gonna hit and it'll be no problem. The issue is that with such a narrow ramp, it's very low profile. Now it's less likely to sink into the floor because it's so wide, so you can see significantly wider than the first one, but we all know that if you have enough plates stacked out far enough, they'll start to sag at the end. So I don't know if this is too low. And there's a third option to improve on this. I made this one. Now this one says deadlifts, that way I don't forget what it's used for. It's also significantly taller than this one, as you can see. I will have no problem keeping the plates off the floor with this. It has a longer, lower ramp than the first one, but it is more aggressive than the second one. It's also narrower than this one. That way, although I have to be a little better with my aim, it's less likely that it's gonna stick out past the plate and get in the way of the new plates. So I'm going to test all three of these. And when it comes to 3D printing, you can do a lot of stuff to make things, especially for a gym, as strong as possible. For example, I could make it so that these were solid, but most of the time with 3D printing, in order to save on material and to save on printing time, you don't have solid pieces. There's some level of infill. Now, I didn't want to make these 50% infill or 100%. I made these a standard 15% infill. The reason is, I don't know which design I like best, so I just wanted to try these out first. Another reason is that in my mind, it seems like because these will be flat on the ground, where 100% of the surface area that's contacting the ground will be supported, it seems like this doesn't need to have 100% infill, or even 50%. It seems like even minimal infill should be okay, because there's no twisting force, there's no torque being applied, I'm not dropping weights on top of it. It just has to statically hold the weight as I load and unload plates. So to save time, to save material, these are all very basic PLA, 15% infill, nothing fancy, but I'm gonna see how they do. I'm gonna see which design I like best. I'm gonna see how strong they really are. The next thing is collars. These are the standard collars most of us use. This is the modern style. It's very cheap, they're very easy, but they kind of suck. I decided to make what I hope is an updated version. Now again, I don't know how much I like this design. I have to test it first. And because I don't know if I like the design and I wanted to save on material and save on printing time, this also is just standard PLA, 15% infill with a cubic metric. There is technically a chance that it could fail due to the fact that it's only 15% infilled and it's not 50% or 100%. All right, so as you can see, I was able to get 8 plates on, but the 9th plate will not go on. After 8 plates, it is hanging down low enough that it is now coming in contact with the ground, and the 9th plate is a no-go. Now, technically, I could still slide it on if I just use a little bit of my effort and lift the end of that bar. But again, if we're just looking at the ease of sliding on or taking it off with no additional effort lifting the bar myself, 8 plates is the limit. And other than that, hasn't broke. There's no cracking noises. It seems to be holding it just fine. So now with these 8 plates, I'm gonna roll it off and roll it on a few times and see if I can get this deadlift wedge to crack or break or have any sort of damage, or if it's going to be okay. Broken. This is what I was saying about the internal structure. This is just very basic grid style internal structure, not cubic. Now for static hold, it's no problem. But if you were trying to load and unload this amount of weight, this is what's going to happen. This was the second attempt, much lower profile, but much wider. This one also only has a 15% infill, but it is a cubic infill, so it is stronger than the grid infill that was on the first one. And now I'm just gonna keep the 8 plates on there, and I'm gonna see if I'm able to roll these up onto this without it breaking. Now this one's obviously stronger than the first one. It's still only 15% infill, but because it's lower profile, it has a wider surface to distribute the load, and the infill is in a cubic pattern rather than a grid pattern, it's much stronger. And I can roll this up and down, back and forth with no signs of stress. But because it's so low profile, these plates are still touching on the very end. I'm gonna try my third design and see if that's the happy medium between both worlds. Now this third design is already much better. Despite the fact that it still has a very low infill, that stronger cubic internal architecture is not having any problem supporting these 8 plates, despite the fact that the weaker grid style internal architecture of this one made it snap immediately. Also, because it's thicker than both of the other ones, these plates, as you can see, are still off the ground, no problem. I can actually pass my finger right under it. So I'm gonna load even more plates on here, see how many I can go before it's just sagging too low, and then however much it is, I'm gonna roll it up and down and see if that deadlift wedge can handle it without breaking. Now in this case, I have 11 plates stacked on here, and it's holding it no problem. Not only that, but there's still a bit of room under here that I could easily slide another plate. The problem is, there's not much room left. I could theoretically slide one more plate, but then I would not be able to hold an actual collar to keep the plates on. I'm gonna keep these 11 plates, and I'm just going to focus on trying to unload it and load it a few times and see if it can physically hold that weight while it's going up and over that ramp, or if maybe I am able to load it or unload it, since it has such a tall, aggressive ramp and there's so much weight on this bar. All right, it's taking that no problems. I don't hear any cracks, I don't hear any creaks. It seems like it's absolutely perfect. So I'm gonna try something different to see if I can get this thing to fail. So to recap, the first design, not so good. This has a 15% infill. It's just a basic general purpose infill. This is also a grid style infill, which is also general purpose. Didn't do so well. With both of these, I bumped it up. I used a cubic infill architecture rather than the grid architecture. And the whole purpose of that is supposed to be, in theory, that it's way stronger and it's good for things that are load bearing. And in this case, absolutely. Not only did we go from 8 plates completely popping this like a balloon the very first time I tried to actually unload it. Then we went to this, which got me to the same 8 plates. I could load it and unload it all day long, no problem, no creaks, no problems, no signs of use or damage or wear at all. This is good to go probably forever. The problem is, it's low profile. So you can't really load more than 8 plates without them touching the ground. And then you gotta lift the bar again anyway. This being the third design, this is the tallest by far. It's a little narrower. And again, has the exact same internal architecture as this one. It's just taller and has a more aggressive ramp. It held 8 plates. then 9, then 10, then 11, and finally 11 and a half plates. As a matter of fact, it was 11 and a half plates, plus I had a 10 kilogram plate in my hand. I weigh about 100 kilograms, and I was standing on top of it, and I also jumped up and down, and even with a grand total of 350 kilograms on top of this one little wedge, as well as me jumping up and down, which is causing shock force to go through it, no creaks, no cracks, no problems. It's good to go. And as it says right there, this thing was made for deadlifts. But now I need to test these crappy collars that everybody's used to and nobody likes versus these collars that I printed and seeing which one works better. The only potential downside is that because I don't have any rubber on the inside, it might not grab as strong just through lack of friction. But it should have way easier time clamping and unclamping while biting down harder than this one, and also clamping down on more surface area while taking up less space on the bar than this fat boy right here. First test should be no problem, hopefully. Just 40 kilograms that we're pushing down on the collar. Oh, you suck. Just 40 kilograms and it's sliding down. This is just sad. It's still going. Terrible. God, it's no wonder why everybody hates these things. Now let's try mine. Hey, look at that. No problem. Huh. Well, 4 plates or 80 kilograms is also not a problem. As a matter of fact, you know what? I'm not going to keep loading plate by plate. I'm just going to step on top of this and kind of see what happens. Now, either this is going to be awesome or it's going to be catastrophic. We will see. Interesting. When I was accidentally twisting around, with that twisting motion, it started to slide. And now it is slowly starting to go, but I weigh 100 kilograms and there's 80 on there. So that's 180 kilograms plus a twisting motion that was required to get it to start sliding. So as you can see, this is simply a better design than this. This again was a prototype. This has a very low infill. It doesn't have any specialty grip material on the inside. It's a very basic kind of what I call entry-level idea. You just clamp it down and it squeezes and it stays on. Similar to this, but designed better than this. And as you can see, despite the fact that this is actually from some sort of company that does this professionally and it has special grip material on the inside, this immediately, the very first test, which was supposed to be a control test, it was supposed to be easy, only 40 kilograms, this immediately failed. This actually held 80 kilograms plus my body weight, which comes out to 180 kilograms. So not bad for a 3D printed part. Now, even though this did work very well, there are a few things I can already tell that I'll be able to do to improve the design. For example, I will make it a thicker infill just in case. On top of that, I'm going to put a grip material on the inside. I don't know if you can see this, but because this is such a long lever arm and it's clamping at the top, it means that even when the top is touching together, the bottom still has a little gap in it. So what I'm going to do is, instead of having the two internal surfaces of these ears running completely parallel to each other, I'm going to have them going away from each other a little bit. That way they can clamp much closer at the top and actually completely close it together at the bottom, and just again be a much more complete uniform clamping force. For a very first print, a very first test, this turned out very well. I'm also extremely happy with my little deadlift buddy here, and I can't wait to try some new things. This has been a success. Anyway, thank you for watching, and I will talk to you next time. Bye.